In this video, we're going to review on how to find least common denominators, and we're going to extend that to rational expressions. I just realized I have the wrong title here. That should actually just be least common denominators for rational expressions. That really shouldn't be there at all. I should just get rid of it. There we go. All right, ignore that. Okay, so when we're talking about adding or subtracting fractions, we need what's called the least common denominator or a common denominator. In other words, we can't add two fractions that aren't broken up into the same number of pieces. So when I'm talking about 2/5, that means I'm looking at something that's divided into 5 pieces and it's selecting 2 of them. And when I'm looking at 3/4, it's something that's divided into 4 pieces and I'm selecting 3 of them. So when you're trying to add pieces that are broken up into different amounts, it's difficult. But if they're the same amount, it's very easy. So we get this least common denominator or lowest common denominator, same difference, to make it easy for adding. So to do that, we focus in on the denominators and we say, okay, so looking at 2/5 plus 3/4, if I wanted to add those two together, a common denominator for them would be 20 because both 5 and 4 divide into 20. How do you come up with 20? Well, 5 times 4 is 20. Technically, 40 could work because both 5 and 4 go into 40. But we're always striving to find the smallest number possible because the smallest number means that we will make the smaller amount of mistakes and it makes our life a lot easier. So for this first problem, the LCD is actually 20 because both 5 and 4 go into 20. Now, looking at this next one, though, a common denominator could be 18 if I just multiplied the two together. However, if I'm really like paying attention, technically 3 goes into 6, which means I could just make 6 the common denominator. Both of the numbers divide into 6, and that would be the lowest common denominator. So when we're looking for common denominators, we don't just multiply the two of them together. We actually look at the numbers and see, is there something in common that's smaller than the two numbers multiplied? And there's a few ways to do that. I'm going to kind of introduce what I think is going to make our life a little bit easier. And it's what we kind of did when we were doing the multiplying. And that is we're going to kind of break it up into common factors. All right, so let me show you what I mean by that. So I see 6x squared and a 9x. So just looking at the 6x squared, if I wanted to rewrite 6x squared, I could think of that as x squared is x times x, and 6 is 3 times 2. I'm breaking it up into what's called the prime factors. 9 is 3 times 3, and it has an x. So here's what I'm going to do. They have in common a 3 and an x. They already have that in common. But the first denominator has this extra 2 and an extra x. And the second denominator has an extra 3. So the LCD is going to be made up of what they have in common, which is the 3x, and the extra pieces. So that 2 from the first one, and the x from the first one, and the 3 from the second one. So I've placed the common term, that's this right here, what they had in common, these 3 x's. And then everything that's left over, I went ahead and I put over here. And if I multiply that out, 3 times 3 is 9, times 2 is 18, and then x times x is x squared. There it is. That is the common denominator, 18x squared. And if I look back at what I started with, the original problem, it kind of makes sense. 6 and 9 both go into 18. That is the lowest common denominator. And x squared happens to be the biggest of the two x's. So it ends up being what we have in the denominator. Okay, so let's kind of take that approach. And we're going to use this idea that it became easy when we broke it into multiplication. So once again, we're going to factor. Oops. And factoring is going to help make our life a little bit easier. So let's look at this first example here, or I should say second example here. So we have an x plus 3 and an x minus 5. I can't factor those. Like I literally just said we're going to factor, but I literally cannot factor those. They don't have GCFs. They're not difference of squares. So I can't factor them, which means they both just have to be in the LCD. If they can't be factored, they just both have to be included. And that will be the LCD. It's kind of like equivalent to what we did up here when we had the 5 and the 4 in this kind of fraction example, and we just multiplied the two of them together. It's kind of like what we have to do here. Okay, that's boring. Let's look at when we actually have to factor. Okay, here we go. This one's got a factoring. X squared minus 4. That's going to factor into x plus 2, x minus 2. But the second fraction, that's not going to factor. That's just an x plus 2. Okay, but what I notice is they have an x plus 2 in common. So that's going to go into the LCD, what they have in common. And then they have this extra piece right here. Sorry, that's what's in common. The extra piece of x minus 2 is also going to go into the LCD. That's the extra piece. And that's the answer. I don't have to multiply it out. I can leave it in factored form, but the answer is x plus 2 times x minus 2. All right, let's try that again. All right, so this one's more exciting, more factoring. Okay, let's start with the first one. I'm going to use the x method. And I can use my shortcut. So let's see, top of the x is 25, bottom is negative 10. So that'll be negative 5 and negative 5. Okay, so that's going to factor into x minus 5 times x minus 5. All right, that's what that first one is. The second one, that's going to be 45 and negative 14. Okay, so two numbers that multiply to be 45, but add to be negative 14 would be negative 9 and negative 5. Okay, so that's going to factor into x minus 9, x minus 5. Okay, so these are the two fractions here. Okay, so what do they have in common? X minus 5. So that's going to go into the LCD. I'm kind of out of space here, so I'm going to write it over here. So x minus 5 is in the LCD. Okay, and then what's extra? There's an extra x minus 5 and an x minus 9. So that's going to go, oops, into the denominator. And that's the LCD. If you want, you can write the x minus 5 as x minus 5 squared because it's twice. That's fine. But yeah, that's the LCD, and that's the answer. That's what they're looking for, are these lowest common denominators. So we're putting what they have in common, and then the extra pieces we're just tagging on at the end. If they don't have anything in common, like on this one, they both go into the denominator. And then on this first example where we're working with something kind of in already factored form, we kind of broke it up into the primes and found what they had in common. And then we did go ahead and multiply the final answer, but you do not have to do that when they are in factors like this. They'll even say in the problems that you can leave your answer in factored form.